Welcome, folks. We're just getting started here. Alyssa, are you keeping an eye on the entry for me? Thank you. All right, looks like we're getting a critical mass in the room, so I'm gonna just let us get going. Quick reminder before we dive into things that we are recording this webinar, so please mute yourself and choose your video status accordingly, whether you'd like to be on or off. All of these monthly science seminars are archived on the Midwest Climate Adaptation Science Center's YouTube channel. So if you would like to rewatch this one or see a past one, you should check us out there. I'm Jess Del Fiacco. I'm the communications manager for the CASC, and I'll be helping moderate today's session. But before we get there, I'm going to welcome my colleague Alyssa Welch to tell you a little bit about who we are.
Thanks, Jess. Hi, everyone. My name is Alyssa Welch. I'm the program manager for the Midwest CASC, as Jess said. Thanks, everyone, for joining us here today. So for those of you who have been a part of the science seminar before, the spiel will sound a little familiar to you, but I'm just going to provide a little background to get us going here as a reminder about what we do and how we do it. So we are a consortium and a partnership between the USGS and 8 institutions across our Midwest region, which is hosted at the University of Minnesota. We're also part of a national network of regional CASCs, our Climate Adaptation Science Centers. And together we all work to produce science that seeks to inform research management efforts that help fish, wildlife, land, water, people adapt to a changing climate. The work and research that we support centers around a set of science priorities that the Midwest CASC has set for itself, and those can also be found now on our website. I imagine just hearing that will probably drop our website into the chat for you now. So at the Midwest CASC here, we accomplish our mission to those science priorities in a variety of ways, including conducting synthesis research, providing a network and platform for graduate researchers and postdoc fellows. We partner with consortium member College of Menominee Nation to offer a tribal REU program. We host workshops and an annual gathering. And we also serve as the pass-through funding mechanism with USGS for climate adaptation research projects and partnerships. So that's a little bit about a background about us. For our announcements today, as I just mentioned, we have an annual gathering. This year, we are coming to East Lansing. We are delighted that our consortium member, Michigan State, has offered to host this year. 2 years ago, we were in Madison, Wisconsin. Last year, we were down in Indianapolis. So we're excited to be making the rounds. I don't think registration has quite gone up just yet, but do stay tuned for that registration portal to open as we finalize the details for that gathering in August. And then next, we are very excited to launch a separate but related webinar series that we're calling Innovation and Adaptation. And our first speaker will be Emily Wasley on March 7th. Emily, as you may know, is the lead author for the NCA 5 adaptation chapter, and she'll be talking with us about transformative adaptation. So I hope you can all join us for both of those events. Jess, I'll pass it back to you for the intros.
Yeah, well, actually, we have one more fun announcement for today. Holly, if you want to say a couple words.
Yes, thank you. So my name is Holly Emke. I am a research fish biologist with the Midwest CASC, and I want to welcome 2 visiting scientists that we are excited to be hosting for this week through the Next Gen Mekong Scientist Program. That's a State Department funded program. So Selah and Kim are here with us at the Midwest CASC. They're here, they're waving. And so they are here through the Next Gen Mekong program, which is a program aimed to empower early career professionals in the Mekong region to increase science policy engagement, build working relationships among future leaders, and foster sustainable stewardship of the Mekong River Basin. And so Kim is visiting us from Vietnam, and Selah is visiting us from Cambodia. Both of them have expertise in fisheries and sustainable livelihoods, and so we'll have a few opportunities for Selah and Kim to engage with the broader Midwest Cask community throughout this week and on to the future. So I'm going to just hand it over very quickly to Selah and Kim to say hello.
Hello, I'm Selah from Cambodia.
Hello everyone, I'm Kim Quyền, just call me Kim. Nice to meet you all.
Thank you so much. So Jess, I'll hand it back to you.
Yeah, thanks, Holly. Thanks. Welcome to Selah and Kim. We're happy to have you here and learn more about your work. And that is the end of our announcements. So I'm going to hand things over very shortly to today's speakers. We are very happy to have two experts on grassland management with us today. We have Melinda Smith, who is a plant community ecologist from Colorado State University. And we have Brent Rudolph, who is the Director of Sustainability Partnerships with Pheasants Forever and Quail Forever. Melinda, I am going to hand things over to you first. Melinda's going to share a little bit about her work with us. Let me stop sharing my screen. There we go.
Thanks for the opportunity to come talk to you all. I'm going to present today on some research that we've been conducting globally on drought impacts in grasslands, and at the end I'll give some key kind of takeaways that are relevant to management, maybe thinking about management in the future with more extreme, more intense droughts that are likely to occur with changing climate. So let me make sure that I can share this. Okay, everybody see that? Oops.
Yep, looks good.
I'm not sharing the right screen, it looks like.
We can see the drought impacts on grassland slide.
Okay,
so
great. I can't
okay.
tell. Thank you.
Looks right from here.
Awesome. Okay, so I'm going to talk a little bit about what we've learned from this global network of drought experiments and what that can tell us about how we might manage for drought in the future. Just to give you, as indicated, I'm a plant community ecologist, but I also consider myself an ecosystem ecologist. I work exclusively in grasslands, and I'll talk a little bit about that. And the method I employ are experiments, trying to really get at some of the mechanisms that underlie responses to different drivers of grasslands. And I'm showing here the tall grass prairie, which is where I embarked on my career as a scientist, and I continue to work there, but I also work in a number of other grasslands in the Great Plains, as well as in South Africa and in China. And this is just, I know this is busy, but what I wanted to convey with this is kind of what my research program tries to tackle, is how human-caused global changes are, such as climate change, eutrophication, altered disturbance regimes, are impacting plant community structure and function. And I'm going to talk today about climate extremes, and in particular droughts and their impacts on grassland functioning. And what I'm going to refer to primarily is above ground productivity, or AMPP, which is just the growth of production on an annual basis. And it really has important implications for carbon cycling, as well as forage production, and how we might manage these grasslands for one of the major functions that they serve, which is the production of livestock. Okay, so global context, grasslands, they cover about 40% of the Earth's terrestrial land surface. And actually, if you ask a forest ecologist, they probably would say forests cover 40% of the terrestrial land surface. But this is grassy biomes, and if we're thinking about your Midwest cask, right? That's smack dab into the middle of the Great Plains, which historically was important grasslands like the tall grass prairie. a lot of it has been converted to agriculture, but quite a bit remain. And so I'm going to talk today about how there is, forecasts for droughts being more frequent and severe in the future, not only in the Great Plains, but globally in a lot of grassland regions. And what I'm showing here is just, for example, the 2012 drought. If you all experienced that, it was quite extreme, and it's kind of indicative of the kind of droughts we might expect in the future. So what are the expectations on how grasslands might respond to these droughts? And let me go back for a second. What I'm showing here too with the 2012 drought is that drought was what often is occurred as a mega drought, in that it impacted multiple regions at once. It's much like the Dust Bowl did, and those kinds of droughts are expected to be more common in the future. And so when we think about that, we want to understand how and why maybe different grassland types might differ in their sensitivity to drought. And there's some indication to suggest that might be the case. So what I'm showing you here is an analysis we did back in 2004, where we looked at the relationship between precipitation on an annual basis and that AMPP, or that productivity. And these, in the main figure, those are just the relationships between the precip and the productivity. But in the inset is the slope of those relationships, which shows that sensitivity, or that slope of the relationship between precip and productivity, is steeper as the drier you get. And based on that, you might say, oh, well, maybe, based on kind of the nominal variation that these sites experienced, those drier sites tend to be more responsive, and thus may actually experience greater losses if they experience drought. And when you look at the 2012 drought response, just in the Great Plains grasslands and desert grasslands that I'm showing here, that kind of relationship holds. So those drier grasslands tend to be more sensitive than wetter grasslands. And you might be thinking, well, actually, wouldn't you expect the opposite? Maybe that, these drier grasslands, they're well adapted to dry conditions. Wouldn't they be better suited to being resistant to drought? And this analysis at least suggests that that is not the case. And so we, to further kind of understand how grasslands, not only in North America, but more in a global context, might vary in their response to drought, we established back in 2014 the International Drought Experiment, and this was motivated by a larger project called DroughtNet, which was funded by the National Science Foundation as a research coordination network. And this is one of the key activities that came out of it. And right now, there's 143 sites that are conducting this coordinated experiment across the globe. And for the analysis I'm going to show you next of these data, we looked at 100 grassland and shrubland sites that had imposed drought for just 1 year. And our target was a 1 in 100 year drought, so something that was extreme. And we based that on each individual site's historic record of precipitation. So as you can imagine, that might mean that some sites are reducing rainfall more so with their shelters than others, depending on what their historic variability was and what a 1 in 100 year drought might mean to each individual site. And what we found was that the global pattern of drought response, meaning the loss of productivity with drought, these experimental droughts, when they were extreme, when we hit that target of a 1 in 100 year drought, the losses were much greater than when we did not hit that target. So because these drought shelters are reducing ambient rainfall, it just depended on what kind of rainfall each individual site got. And if that site was at average rainfall, for a long-term average rainfall or below, we could hit that target of extremity. But if they were above that the mean annual precipitation for the site, unfortunately, we couldn't hit that 1 in 100 year target, but we were still imposing some kind of nominal drought. And so when those droughts were really extreme, that loss of productivity was 60% greater. And with this gray shading, that's kind of the averages of losses in productivity that have been published in other papers. And so it was much greater than what we even got from past studies of a drought. And we think that is because we really did push these systems to these kind of extreme levels of drought that are expected in the future. But I want to note that there's a lot of variation among the sites in their drought response. And I'll show you here here's the shortgrass prairie, which is in the western part of the Great Plains. And here's the tallgrass prairie where you guys are at in the Midwest. And the tallgrass prairie is much less responsive to a single year drought than the shortgrass prairie. So that's just one example of how variable it can be. And a lot of this variation could be explained by the fact that, again, much like that expectation I showed you earlier, drier sites or more arid sites tended to be more sensitive or experience greater losses than wetter sites. And we also found that sites that had lower richness of species or numbers of species in the sites, those were more sensitive too. So you might be asking, well, what about when you go beyond a single year, right? The expectation in the future is that a lot of these really extreme droughts might extend over multiple years. And one expectation is that you could see a loss of function over time, right? Maybe a linear decline. Maybe you get a big loss at first and then a kind of leveling out. Or perhaps you don't see a response at first, but then you get a response that accumulates over time. So maybe it's more like a asymptotic kind of relationship. And so we analyzed from this international drought experiment data from 70 sites. And what we found was that if you look at the green, the grassland sites, and this is years of drought, so sites that imposed up to 4 years of drought and their production response, that you get a loss in that first year, much like I showed you before, but then that loss kind of is maintained. It's not, we don't see an accumulating drought response over time when we look across all the sites. However, when we looked at whether the site experienced multiple years of extreme drought, that 1 in 100 year drought, that's where we saw time mattering. And so when you have back-to-back extreme years, much like we saw in the Dust Bowl, for example, that's where you get the really big losses in productivity. And that's really a death knell for some systems. And I can just say from my personal experience at our site at the Shortgrass Steppe, that's where we saw some of the biggest losses in productivity were these back-to-back extreme years. But just some key takeaways. We found that a single year drought, when it's extreme, when it's hitting that like really, really extreme level of reduced precipitation, that can increase productivity losses more than 60%. But there's a lot of variation in the drought response. Some sites experience big losses, others are quite resistant, which is really cool. And really, we need to understand why that's the case. We did some of these broad kind of measures, and we saw that drier, less diverse grasslands are more susceptible. But there's a lot of variation we're not capturing. And so that's really the challenge for us in the future, is to try to understand this variation. And drought over time doesn't necessarily increase a loss in function or productivity, but when there are those back-to-back extreme years, that's when loss really becomes large. And we need to, again, understand why those losses emerge. And so with that, I'd be happy to take any questions, but I want to just emphasize, this is research, experimental research, but the results that we get from them, I hope will go far to helping to inform management, because it's really this understanding of beginning to dig into why and how systems vary in their response to drought is going to be a key piece of the puzzle that we bring to bear to this really wicked problem that we're going to be facing in the future. So thank you so much. I hope that's informative to you all, and I look forward to talking to you about it further. And I'll
Thanks,
stop sharing.
Melinda. So we probably have time for one question. If someone has one ready to go, we could ask a question of Melinda now. Otherwise, we'll have time after Brent's presentation to talk a little bit more. So if you've got a question to ask, go off mute. I'll just hold for a second while we get ready for our next presentation.
Hey, Melinda. Let's see, am I on video? No. There we go. Hi, yeah, I have a quick question. Super interesting research. When you're looking at some of the impact of these extremes and finding that, you know, the extremes are having a larger impact than some of the more nominal droughts, do you have any expectations for thinking about recovery in relation to those extremes, or any interest in looking at if recovery is particularly different in response to an extreme versus the nominal drought?
Yeah, that's a great question. And we're actually starting to collect data from participants in the network because I didn't get into this because short time, but you know, the intention with this international drought experiment was folks were going to impose a drought for 4 years and then remove the shelters and then look at recovery. And so we're at that point where people are starting to actually look at recovery. And so we're starting to get data sets. And that said, I think that what we're going to find is that often that it's going to be, I think we could say that if you had a larger loss of production during the extreme drought, that recovery might be attenuated. You know, it might take a while for recovery to occur. But I want to just say that there's likely to be some site modifiers, you know, some characteristics that might allow some sites to just be more responsive than others. And I think that has to do with, are you a dry site or a wet site? And the reason I say that is because just from my own experience working in tallgrass prairie versus shortgrass steppe, we see recovery it takes a while for shortgrass steppe to recover because often their losses are really large and we actually lose species when we have drought. Versus in the tallgrass prairie, we tend to only lose really uncommon species and the common species remain intact. And so we can see recovery occur like the year after even really extreme droughts. Hopefully that answers your question.
Yeah, absolutely. Thank you.
Great, thanks.
Okay, Brent, I'm going to hand the floor to you. If you're ready to go.
Perfect. I'll take the virtual floor from you. And let's go. So thanks to all of you for your time here. Thanks to the CASC team for pulling this together. I think we've got a great 1-2 pairing of kind of perspective that we're sharing with you here today. And I'm really looking forward, especially to the conversation at the end. So with that in mind, I'm going to truck right on through and get rolling. So I've got a few high level, but somewhat ambitious topics I want to discuss with you here today. First of all, I'm going to give you a broad overview to Pheasants Forever and Quail Forever into our relevant work in this area. I'm going to talk about upland habitat and connections to sustainability and ecosystem services. And by ecosystem services, I would include climate change mitigation and resilience there. But broadly speaking, there are other connections as well. And then, hey, let's talk about agriculture while we're at it. That's a quick topic to fit into my 10 to 12 minutes as well. But you'll see me kind of thread through these different themes, and I'm going to hit a scope zooming from everything from global down to focusing in on relevance to the CASC region here in the Midwest. So Pheasants Forever and Quail Forever has a mission to, yes, conserve pheasants, yes, conserve quail, but also other wildlife through habitat improvements, public access, education, and conservation advocacy. So we have multiple pillars of the mission, but you'll see with our logos here on the top, we refer to ourselves as the Habitat Organization. So the emphasis is really strong on providing science-based delivery of habitat on the ground and reaching those wide variety of other ecosystem service and social benefits as a result, really. We are a grassroots and boots on the ground organization. So we work alongside a lot of scientific delivery and assessment, but focus again on work on the ground. We have chapters nationwide, and this figure is already out of date. We continue to expand across the country. A lot of our team focuses on that science-based delivery of conservation on working land. So farms and ranches around the country. Our biggest grouping of those folks I would refer to as the Farm Bill biologists. So with that asterisk there, you can see the acronym soup of those conservation title Farm Bill programs that those team members help to deliver. They're doing one-on-one in-field consultations with producers, with landowners. They provide technical assistance. They write management plans. They help advise opportunities for cost share and enrollment. Can walk people right through those federal programs. And they serve a variety of other beyond Farm Bill and even state and more local conservation programs as well. Another team grouping that I'll highlight are what we call our precision agriculture and conservation specialists. You might hear me call them precision ag and conservation specialists, or PACS with the acronym there. This is a smaller, newer team that really is built around making a business case for habitat. So trying to reach out to producers on the ground to help demonstrate how putting habitat on the ground and putting conservation practices to work can be just a good business decision case to make as well. We could talk a little bit more about how that helps overcome a lot of the recognized boundaries and barriers and obstacles to voluntary implementation. But the bottom line is it could be anything from helping identify how those marginal acres, those underperforming farm acres, generally are a drain on sustainability. You're putting a lot more resources for a lot less yield on those acres. So if you got a farmer interested in selling into a supply stream that has commitments around sustainability, we can help identify ways that they can improve in that regard. Again, identifying how conservation program payments can be part of their operation on the farm. We increasingly are working towards monetizing ecosystem services, so being able to deliver carbon credits, increasing interest around biodiversity credits as a way to help provide a source of income for growers and a source of financing to offset conservation work. And ultimately, it all becomes part of a package to provide a net profit assessment. So how can you build conservation, the cost of it and the benefits of it, into your overall farm operation to find a way that it makes good business sense to do, as well as doing a lot of great things for the environment, for your community, for your family, and so forth. So we've got a variety of other folks that are working on different aspects of our mission across the country, but I'll leave it to highlighting that couple groups there to start off with. So really, Pheasants Forever has been for 40 years in the business of sustainability, founded in 1982, out of concerns about declining pheasant populations and upland habitat. The hunting-based approach to conservation, I would argue, is also strongly aligned with sustainability. Forego the opportunity in a given season to take everything you can into your game bag by having restrictions, rules, and regulations that allow for the sustainability of that population over the long term. But specifically looking at, again, connections to one of the featured Farm Bill programs, we help deliver the Conservation Reserve Program, or CRP. If you look at the pheasant population index leading up to the years where Pheasants Forever was founded, it was declining about 1.4% per year, the blue dots with the trend line through it from the mid-60s up into the mid-80s. When the Conservation Reserve Program was created and enrollment took off, that population decline stopped and began a slight actual upward trend, more so even in the core pheasant range states and core states where CRP enrollment is highest. But with caps and other limitations to CRP, as the enrollment has declined, that pheasant population decline has continued, right? So we have a network of members and partners that are substantially concerned about that. But again, our mission and the conservation community we work with more broadly recognizes broader concerns about the decline of grasslands in North America. The 2022 U.S. State of the Birds Report noted that grassland birds had experienced the most substantial decline of any terrestrial biome that's been monitored since the 1970s. Due in large part to the conversion of habitat to agricultural land. In some of the western and southern ranges, you have substantial concerns about tree and shrub encroachment and the variety of pesticide applications that negatively impact brood rearing and other things within that region as well. Look at another conservation organization, the National Audubon Society, their North American grasslands assessment identifies that and included an assessment of climate strongholds, so looking where birds are best likely able to endure the concerns and impacts of climate change in the future. They really identified the mixed prairie, the shortgrass prairie shifting out of the Midwest region as the areas of strongholds for birds with conservation, with negative impacts on conservation and negative effects from climate change. But acknowledge that that tall grass region, which we get into the Midwest Cask states, Minnesota, Wisconsin, Iowa, and so forth, really has some remnant grassland areas that are prioritized and incredibly important for conservation, but that operating in those areas is much more challenging because of the higher value of land in the region for other uses other than conservation. So we have this nexus of concerns that we're trying to address to be able to identify the top priorities within a region that's seen the most dramatic impacts, and a challenge of finding a way to be able to meaningfully engage there. So shifting back again to looking at the pheasant conservation plan, but looking at broader benefits of those conservation programs like CRP, the Conservation Reserve Program. The blue counties highlighted previously were the pheasant range counties. You can see within that kind of arrowhead pointing towards southern Michigan, northern Indiana, most of Illinois. That's the tall grass prairie region. The acreage enrolled in CRP at that time, early 2020s, around 2021, constituted reduced carbon emissions and increased carbon sequestration equivalent to 12.7 million metric tons per year. So having that land enrolled in CRP, rather than being planted to traditionally row crop agriculture around that region, was the equivalent of sparing the emissions of about 2.8 million passenger vehicles. So that's more vehicles than are registered in 38 states in the US, or at least as of that time, 2020. So CRP provides returns value to growers to find opportunities to enroll their, especially their conservation vulnerable lands, into other alternative conservation arrangements and receive payments for that. It provides benefits to pheasants and lots of other wildlife, and it provides a great benefit in terms of carbon sequestration and mitigating concerns over climate change. But again, referencing the Audubon report, it's really hard, even for high quality programs like CRP, to compete with other land values. Basically the return on row crop agriculture in the region. More broadly, agriculture is a huge economic engine. If you look at the value of farmland and the increase in increase in value over time, specifically focusing on Iowa, about the last decade plus a couple of years, the increasing value of the top 10 globally traded agriculture companies is pretty much parallel to the increasing value of Iowa farmland. So the top 10 globally traded companies on the left, they increased in value from 2010 to 2022 by about $221 billion. Iowa farmland increased by about $201 billion. So the value, that land is a commodity. It's used, it itself is a resource for that economic engine for some of the most globally significant companies in the world. And when we take, again, focusing more specifically, there's a lot of information conveyed here, but what we see, the figures on the left, the pie charts, show us that the US accounts for about 1/3 of the global production of corn and soy. So global production world around is from the US. The maps show us that the vast majority of corn and soybean production in the US occurs in these Midwestern states. You can see those really dark colors, again, centered on Iowa, southern Minnesota, some of the portions of eastern South Dakota, Nebraska, are showing that basically that's the core production for corn and soybeans in the globe is right in this region of the tall, formerly, for the most part, the tall grass prairies. It all boils down to the text shown here on the bottom. 60% of global grain production occurs in 5 countries. And when we look at corn and soy, the biggest chunk of that comes from the US. Within those countries, that concentration of production brings some efficiencies. So when you want to minimize the amount of emissions involved in producing your food or other agricultural products and transporting them around, there's some efficiencies for concentrating that. But looking at our intersection with climate change, it creates vulnerabilities for the global food system. So Melinda was sharing some of the shocks to the system from increasing severity and frequency of drought to natural systems. So there's concerns about that to agricultural systems as well. And concentrating that production means if you have a globally concentrated extreme weather event, it can become a substantial concern. You probably remember some of that discussion around wheat failure, crop failure, and intersecting even with the global political upheaval around areas of the world. And that creates these really dramatic concerns about the potential impacts of those future extreme events. So I'm really leaving with the point that a threat and a concern is also an opportunity. We have globally significant corporations that, for a variety of reasons, either to kind of maintain their social license to operate, or because of concerns over increasing interest in regulations, even though the US is not really strong on regulations regarding sustainability and climate, Europe and other areas around the globe are. And as globally traded companies, it doesn't matter if the US is not fully on board. Corporations are seeking opportunities to continue to minimize those impacts, continue to support the transition of agricultural systems to sustainable and regenerative approaches. And that provides an opportunity to offer up upland habitat and other habitat as a sustainability solution on the ground. Find the science-based ways that we can restore habitat in strategically important locations, even alongside those what can be seen competing uses of agriculture. I've had the great fortune to be with Pheasants Forever for about 2.5 years to help continue to try and form that strategy, work with a lot of potential partners, and continue to accelerate the rate at which we try and accomplish grassland and other conservation on the ground. And it's great to have more discussion with the network of folks on here to discuss other opportunities for that down the road.
All right, thanks so much, Brent. We are going to move into the discussion portion of this webinar now. I'm going to, let's see, add some spotlights to get us on your screen. I'm going to welcome my colleague Hugh Ratcliffe, who is an ORISE Fellow and Climate Adaptation Associate with the Midwest CASC, to join and help, oops, we hit the right button, help moderate this discussion. So we've got a few questions that we'd like to ask of Brent and Melinda, but I encourage folks to drop some questions in the chat as well, and we will hopefully have time to incorporate those too. So Hugh, would you like to kick us off with the first question?
Yeah, absolutely. Thanks for letting me ask you guys some questions. I work with a lot of habitats now in my current role, but have a academic background in grasslands. So definitely interesting to hear from both of you. I think this question would work for both of you and can be interpreted kind of in respect to your own expertise. But thinking about, as with any ecosystem, there's a lot we don't know about how climate change is going to be impacting grasslands. What do you see as some of the key knowledge gaps, some of the main things we still need to kind of dig into more, whether that be for thinking about just the ecology of the system, or maybe the knowledge gaps for thinking about how do we make agricultural systems be a little bit more climate resilient and more beneficial to the natural environment? Either of you start. Yeah.
I'll jump in. I saw Melinda come off of mute, but I'll jump in. I tend to focus on a lot of it. There are a lot of aspects that we don't understand fully about how the natural systems, and I would include agriculture, as a natural system in there, how they'll continue to respond to climate change. I still feel like the biggest challenges, especially in being able to navigate those pressing drain on our conservation systems, is understanding how to create socially and economically sustainable solutions to continue to advance conservation practices. There is a lot of information, again, around barriers for individual implementation. Much of it is dependent upon producers that are making choices and have to voluntarily implement, particularly in the US. There's a lot of information around the economic challenges, the complexity over programs. There's challenges with land tenure, in agricultural systems. Many folks are are farming land that they don't own. They might not have long-term arrangements and agreements. So it comes down to needing to make an individual year choice, or even sometimes an individual season choice. And so we need to continue to find ways working across agriculture and conservation communities, I think, to navigate those barriers and have consistent, key, simple principles that producers can use to, again, translate to how it's a smart business decision for folks to make, and incentivize the right practices that are also important conservation and natural resource outcomes accompanying them.
I want to go back to your question when you asked about recovery, because I think that's the big big frontier for understanding. We don't have very clear understanding of recovery dynamics, and that's really important when we think about. I'll use livestock management. During drought, you have to take cattle off, and you can see it unfolding. It happens. But then the big question is, when do you start, managing those grasslands again after you come out of a drought, which you don't know when that's going to happen either. And so, I'll just give an example of some research we're doing right now is trying to get a sense of how, like, post-drought, once you start to get precipitation increases, where is that point in which you start to get recovery? And unfortunately, at our shortgrass steppe site, what it looks like is that intervention is going to be necessary in that case. And so that's where I think the rubber would meet the road for informing management, is really getting that what happens after these events and how can we manage them, and when is intervention important. And when you look back at the Dust Bowl, there was intervention post Dust Bowl. It had to be done, and I have no doubt that that's kind of a situation we're going to be in sometime in the future. When it's going to happen, we don't know.
I'm looking at some questions we have in the chat. We've got one for Brent, which is, beyond potential regulatory forces, what do you see as driving corporate action and partnerships on conservation? Coming in too fast for me to read. What do you see as a particularly important knowledge gaps on that front?
Yeah, thanks, Jess. So beyond regulatory forces, trends in public opinions, and not just public in general, but consumers or customers, investors, employees. There's increasing interest in and expectations around sustainability, around minimizing negative impacts on biodiversity and natural systems, that are driving a lot of corporate action, or at least commitments, and an increasing number of publicly made commitments around biodiversity and climate, especially. Again, the biggest gap, the biggest challenge, or I think the missing link, is that even corporations with a substantial amount of resources available to them will look at programs as a return on investment. So what's the best way? What's the easiest way? What's the most financially sustainable way to improve sustainability? Not just dumping money into a problem because their boards and their governance requires that they show a return on investment. And frankly, when it comes to conservation, an organization like ours trying to get to restoration of habitats, or even just incorporation of more perennial cover and more diverse systems on the farmscape, that's not the cheapest way to improve your sustainability. And it makes sense that other simpler mechanisms that are still really important, like cover crops, like no-till, like nutrient management, are faster return on investment. So we have to continue to craft ways to be able to deliver to growers the solutions that will be more meaningful conservation outcomes, and really bring in a more diverse set of resources to be able to support that. So it's not entirely put on the corporate footprint. It's not put on the growers that has to come at their extra expense, but it creates a sharing of resources to be able to deliver in a meaningfully impactful way and scale.
You want to ask a question, or you want me to ask another one?
Well, I just want to make sure we get to the ones in the chat, but yeah. Let's see, I can read the next one from
I can answer
JC.
the one about below ground production if you want.
Yeah.
So, as you can imagine, the IDE network, it was hard to ask folks to measure that, in part because we wanted to make it relatively easy for people to join the network voluntarily. We didn't have funds to help support the research, and so everybody did it on their own. But so we don't really have a sense globally in that context, but just from my own research in the shortgrass versus the tallgrass prairie and the responses below ground to drought of that mesic versus xeric, more semi-arid systems, is that in both systems, the biggest losses that occur are in the top 10 centimeters of the soil, which is really, if you think about that, that's like a really important piece of soil retention and soil structure and things like that, as well as carbon sequestration. And so we see losses at that level. Similarly, they're impacted the most in drier versus wetter grasslands. But the difference is the losses are much greater in the drier grasslands, greater percentage loss. And so we've been working with a group at Michigan State University to see what impact that loss of roots in the soil might be doing to soil structure, infiltration, things like that. So the jury's still out on that piece. We're still waiting for those data to come back, but it doesn't bode well because we see pretty large losses below ground, and that has an impact also on how much carbon is being released from the soils.
Thanks, Melinda. There's a couple in here for you, Brent. I'm going to try and maybe combine a couple of them. One is, what changes might you like to see to the Farm Bill to make CRP more competitive and effective? And then kind of relatedly, are there any efforts to adapt conservation programs for situations where landowners rent their land to growers?
Yeah, both great questions. Yeah, I think I see a reference in there is, for CRP, is it about making it, higher rental payments and fewer caps? And yes, those would be important. I think the other priority, not just for CRP, but for any program, is there are also often barriers around the complexity of programs. So in some ways, we also see I think it's important to look at what's the outcome we want in the landscape, and CRP and Farm Bill and other programs are just one way to accomplish that. So finding opportunities for complementing those payments. So can a producer enroll in CRP and also receive compensation for carbon or biodiversity benefits? There's some questions around additionality there. So we get into some research questions, again, on also the social side as well. How much can you account the payment for a carbon credit as incentivizing a practice change compared to a payment from CRP if they're both occurring at the same time? Those are key questions to be able to help address and make sure that we're really getting benefit from investment. But I think being able to bundle those programs together, or even just offer them as alternatives. Maybe someone doesn't want to enroll, they're uncomfortable enrolling in a government program, but they're okay with a private offered ecosystem service credit program as another alternative. So being able to find ways to meet growers and landowners where they are is important. Regarding the question about, are there systems that consider the difference between producers that may or may not own the land and those that own the land? Again, it's a challenging system to navigate, but in some ways it's also an opportunity. There may be times where, say, a landowner is not eligible for a program based on their income, but someone that they are renting land to for operation is eligible. So the best opportunity is when you can work with both of those folks and find what works best for the land and for both of them collectively. But it does add another layer of negotiation and navigation with the different people involved in those decisions.
Yeah, I have a question for you, Melinda. I think this actually also ties into some of the background that Brent was talking about in terms of the history of these grassland systems, particularly tall grass prairie systems. in terms of land conversion. My question is, do we have a sense of, in some ways, the direction that we expect future patterns of land conversion to change as a result of climate change, particularly when we think about maybe some of these shifting agricultural zones or woody encroachment, kind of thinking about the location of these biomes in respect to climate change?
Yeah, that's a great question. I mean, if we go with the compound effects of warming and shifting variability or even means, which we're not really sure about that part, but we know we have a pretty good sense that variability is going to increase. Then the expectation is that we're going to be drying things out, and if that's the case, sadly, one of the biggest I think anecdotal evidence is from the Dust Bowl again, that Weaver in his assessment of the Dust Bowl impacts showed that there was a shift in C3 grasses into tallgrass prairie. So like things like western wheatgrass became more abundant in central Kansas, western and central Kansas. And so I think there's no doubt that we're going to see a shift in kind of where what's dominating particular grassland types. We might see more novel assemblages because of that. And what that means for, continuing climate change is, that's another question. But what we might expect is that that could have huge implications for carbon sequestration, wildlife, all of those things. So, I mean, it's hard to say, but we have some anecdotal evidence that could be the case. And in our experiments, we actually can replicate that kind of increase as well in these C4 grasses, replacing the C4 grasses.
Thanks. Yeah, and I'd like to kind of also pivot that to Brent in terms of thinking about how farmers are thinking about shifting the makeup of their crops based on some of the new climate regions that we, or the crops that we expect to be able to grow in the future. I've seen, plenty of papers talking about how the Corn Belt is expected to shift north. I don't really have a sense of how these growers are thinking about that, and also how that might also be influence the larger discussion about sustainable agriculture.
Yeah, great question, Hugh. I don't know that I've seen a lot about how individual growers are making decisions. Again, the challenge being that it's kind of one season to the next decisions made. So there are, in some instances, decisions made regarding more incorporation of cover crops and other practices that can help increase water retention in the soil, for example. So it's modifying their agronomic practices in that way. There is some expansion of interest in some other lower input crops like sorghum in areas of the high plains becoming a little bit more of interest, and it requires fewer inputs, less water. It's more resource conserving benefits. So there's some shifts like that, but there's also so much a strong tradition. There's knowledge, there's equipment base, there's practices around. If you tend to be a corn and bean rotation farmer, not a lot of folks are looking at how they're going to completely abandon those crops that they have a history with in preference for something else. It's more incorporating different things into the rotation or different practices into the intercropping systems and things like that. How agriculture more broadly can look at shifting regionally, production of one crop or another is a completely different question, an important one, but a little bit different than how we would look at trying to work with individual growers kind of collectively.
All right, I have one more question for you all to close us out, but while I do that, I'm going to put a short poll up, which hopefully folks will answer. This helps us make sure we're doing a good job with these seminars and how we can do better. But this is for both of you. Maybe Melinda, you can start, and then Brent. And I'm curious if we can, you can give me, it's a big question, but in as short of an answer as possible, can you tell me why we should care about grasslands?
I'll take a non-biologist approach and just say the aesthetics and the broad values of the simple existence on the landscape. You know, we've talked a lot about ecosystem service benefits. They provide a lot of benefits to society in many different ways. We also just look at, again, it's often overlooked how globally imperiled some of the systems right here in our region are. It's really important to continue to keep them present on the landscape just for that reason as well.
Yeah, and I would say I think they're important for their direct and indirect effects on humans. If we think about it from direct way, we utilize them for forest production, but indirectly, actually where we do most of our crop production used to be grasslands. And so we benefit from them from, you know, the historic past to the current, to present.
All right, well, we are just about at time. Oh, and Melinda, I see you jumped in and answered a question in the chat too. Thank you for doing that. Brent and Melinda, thanks so much for spending some time with us today. This was a great conversation. I hope folks learned a lot. And Hugh, thank you for your assistance in moderating. Quick reminder that we do have 2 different events coming up. Next week on March 7th, we have our Innovation in Adaptation speaker event. I'm going to drop the link for that in the chat. And then next month's science seminar is going to be all about data visualization with some folks from the USGS Viz Lab joining to share their expertise. So I put that link in the chat.